Hello, today I'm going to be talking about StatModPredict, a user-friendly, shiny dashboard interface for forecasting and fitting statistical models, specifically the ARIMA, the GLM or Generalized Linear Models, Generalized Additive Models or GAM, and Facebook's Profit Model, which for the duration of this tutorial, I'll refer to as Profit. So to download the necessary code and data we're going to need today, you're going to want to navigate over to our GitHub page, which is called StatModPredict, and I'll include the link to this GitHub page under the video as well. Once you've come to this page, you're going to see three folders: the app code folder, the example data folder, and the tutorial folder. So each of these folders contains everything we're going to need today to be able to run an example and to ultimately get the dashboard to load. So to download the code, what we're going to do is go to this code button and then click download zip. So what we'll see then is we'll have a folder go to our downloads folder in our computer that contains everything we're going to need and everything that we see here. So let's hop over to it. So what you're seeing now is my downloads folder. And as you can see, I have a zip folder here. So let's unzip that and take a look at its contents. So as we saw before, we have our three folders. So again, the tutorial, the example data, and our app code. And we also have our license as well. So the first thing we're going to want to take a look at is this app code folder. So within this folder, you are going to see a lot of R files, including one called app, which we'll come back to. This is where we'll get things running. And then you'll also see the StatModPredict project. So this is what we're ultimately going to open to be able to set up our working directories in R correctly and be able to run everything smoothly. Next, we have our example data folder. So these are just two examples of types of data that we could include and use in this dashboard. So the dashboard does work with different temporal resolutions of data, meaning it can work with weekly, daily, yearly, and time index data. And you can see the example or two examples here of how you might structure the input data. And then we have our tutorial folder. So this contains everything we're absolutely going to need today to be able to run the example. So as you can see, we have the HIV national stat models. So this is our input data set. We'll take a look at that in a second. Then we have some outside models, which I'll talk about later in this video, what that means and how you can use those in the dashboard. And then we also have a CSV file containing some performance metrics, evaluating the model forecast performance for these forecasts listed above. And then finally, we have a TXT document containing the data structure that produced these forecasts. So let's first take a look at our input data. So there's not too many restrictions on how you need to structure the data for the dashboard. The main things you need to focus on is this first column here. So this first column is where we're going to specify our dates. So in this case, if we're working with the yearly data, it needs to be specified as a 4-number year. However, if we were working with daily or weekly data, that would need to be specified as year and then dash month, dash date. So like this. And if working with time index data, we would start with 1 and then go through the length of the data. So 1 to 15 in this case. The column names do not matter initially when reading data into the dashboard. So this first column just needs to indicate for yourself that this is some type of date. In this case, I specified it as a year because I wanted to make sure I knew it was yearly data. And then the following columns need to each correspond to a different location, group, or some type of category that you're measuring. So in this case, we're looking at different regions of the United States and at HIV counts. So this corresponds to the Midwest counts from 2008 to 2022. This is for the Northeast, South, and West. Some important things here to note with the data, it does have to be incident data and not cumulative. And what that means is each year needs to include the unique number of counts that occurred in that year. One last thing to note while looking at this data, there cannot be any missing dates. So you do have to have a continuous time series. If that continuous time series is not there, the dashboard will throw an error and let you know that's the case. And then finally, there is absolutely no specifications on the file name. You can call the file whatever you would like, so you know what you're working with and can keep track of your data. And then this does need to be saved as a CSV file, so a comma delimited file. So let me close that out. So now that we've taken a look at our input data, let's navigate over to our dashboard. So again, this is that folder that contains all of our functions. And what we're going to do is go to the StatModPredict project. And this is pending that you have R and RStudio downloaded. And that does need to be done prior to running anything related with this video. You should be able to double click on the project. And it will take a second for my computer to do it, but it will open up R for you. And then you should be able to see your folder containing all of your code you just downloaded in your right-hand panel. So if you've gotten to this point and you see your code down here, R has loaded successfully, you are now ready to run and start up the dashboard. So how we do that, we need to click on this app.r. So this is the only file you're going to need to open for this entire process. And I promise absolutely no coding is involved. We do just need this open to facilitate starting the dashboard. So the app file you should see at the top, StatModPredict, and that's how you know you have opened up the correct file. And you'll see a lot of comments and information, just some information about the dashboard. However, to actually get things to load, all you need to do is click Run App. And keep in mind, when you do open R and load this, you may get a panel at the top of the dashboard letting you know there's a few functions you need to download. Specifically, those functions would include those used in reading in the other functions. So the Shiny function and then the Pac-Man function. However, R should prompt you if you need to download those, and it will let you know by giving you the install button option. But if you do not get that, what you can do then is go ahead and click Run App. And you'll see some information pop up here. So there are warnings that do pop up. You can ignore those as long as the dashboard does open up for you. And I'll show you what I mean by that in a moment. There we go. So you do get some warnings. Those do not mean anything. It is a product of how some of the figures are created. So when you first open up the dashboard, you get your welcome message. So you can go ahead, take a look at that, and then click OK when you're ready to proceed. And then you will be able to see the first page, so the About page. And on this page, you can navigate through all sorts of information included within the dashboard. So how do you prepare your files? How do you prepare your forecast files? And then other information, for example, related to the modeling frameworks that are included. And then there's also information about the evaluation criteria included as well. So on to the fun part. So let's go ahead and get going with our forecasting. So next, what we're going to want to do is navigate to this forecasting page. So when you first open up this forecasting page, you are going to see a lot of link boxes. And then you will have your sidebar here that has a few options showing. However, once you load data, more things will auto-populate, and we'll go through those step by step. So what we're going to go and do then is load up that HIV data we were taking a look at. And to do so, we're going to click Browse. And then navigate to that folder that has our data. So in this case, the tutorial. and then our HIV national stat mods or models. But let's say for a second, you don't know if you specify this correctly, or you think that a TXT file is needed. If we load the TXT file, what will happen is you'll get an error letting you know that you need to upload a CSV. Then you can go back and upload the correct file. So there are quite a few errors built into the dashboard to help catch any potential issues that could occur. And please bear in mind that if you get one of those errors, take a look at either how is your data set up, how is your model specified, and you should be able to resolve the issue that you're having based off the error message you see. But so now once you see upload complete, that does mean the data is uploaded. And then next we need to specify a location or group. So originally no locations or groups are selected. However, if we click, we can see we have 4 options, and those 4 options correspond to the 4 columns we are looking at. So the Midwest, Northeast, South, and West. For this example, what we're going to do is just we're going to look at all of our locations. So I'm going to click select all. So what that means for each of these locations, we're going to get various forecasts, model performance metrics, and all sorts of other things. Next, we need to navigate over to our forecast specifications sidebar. So this is where we specify some information about how we want to do our forecast and how we want to conduct things. So the first thing you're going to see here is this forecasting dates option. So the forecasting dates option immediately auto-populates based off of all potential dates you could produce forecasts from, given the data that you have. So if you remember, our data range from 2008 to 2022. Therefore, we can run forecasts that start from 2008 all the way to a prospective forecast that goes from 2022 onward. However, for the sake of time in this tutorial, what we are going to do is just look at one forecast. So we're going to say we want to set a forecast period date of 2017. So 2017 will be the last year of data we include in our model. Next, what we're going to want to do is specify our calibration period length. So our calibration period length is how much data we feed or train our models with. In this case, you will see you have lots of options with the max being 10. So that max is set to 10 because we only have 10 years of data up to 2017. So including 2017, there are 10 years of data we could feed into our model. And then for the purposes of this example, we are going to set that to 10. However, let's say you want to see what would happen if we fed 9 weeks of data into our model and 8 as well. We could also specify multiple calibration periods lengths to test with each iteration of running the forecast. Now we have to specify our forecasting horizon. So this is how far out we want to forecast, and this is in the unit of the data that we're working with, and that applies to the calibration period length as well. So let's say I'm going to set this to 4 for now. So that means as I'm working with yearly data, I am going to produce a forecast that is 4 years out from 2017. So with the last year of data being fed into the model as 2017, the next 4 years will be forecasted. Finally, the last option we have here is our prediction interval to show. So frequently 95% prediction intervals and prediction interval coverages are used in forecasting or model fitting and forecasting. However, there are multiple options here you can select from if you do not want to work with a 95% PI. Finally, we need to specify some information about the models. So as I mentioned earlier, there are 4 possible models we could work with: our ARIMA, our GLM, our GAM, and PROPIT. So let's first take a look at the ARIMA. So ARIMA stands for Autoregressive Integrative Moving Average Model. So in this case, we use what is called the AutoARIMA function in R. So this is a built-in function. And we provide the parameters that you can specify without having to actually call the AutoARIMA code encode yourself. So here what you can see is we're specifying the lower and upper bounds of the P and Q parameters, which are used in non-seasonal ARIMA models, and then the number of non-seasonal differences. However, let's say you want to consider seasonal trends. You can click this check here, and then you'll also have options for specifying seasonal patterns as well. However, for the purposes of this example, we are going to stick with the default settings. And what will happen is the auto ARIMA function will use these ranges and then try to fit the best ARIMA model it can within the ranges of these parameters that we specified. So now let's take a look at the GLM. So the GLM is a generalized linear model. So in this case, we only have one option we can select, and that is the underlying error distribution we're going to assume. We have a normal, negative binomial, and Poisson option, and you can only run one at a time. So let's say you want to look at the performance of a normal generalized linear model, assuming normality. You would have to run that first and then run the negative binomial or Poisson. For this example, we are just going to stick with a normal distribution. So what that actually means is our model will ultimately become a simple linear regression model, as we're only considering time as our only covariate. And then next we have our generalized additive model. So we have a few more options here, including the number of basis functions, which controls the wiggliness in a generalized additive model. And then we can also specify our smoothing term for our basis functions. In this case, this 10 comes from the calibration period length, so it is a function of the calibration period size. However, that can be customized, as with the smoothing term used as well. And then, as with the GLM model, we do have multiple error distribution options too. And finally, we have our profit model. So here we have three options. We can specify the type of growth trend we want to consider, so either linear or flat. Our seasonality we want to consider, so there are more options here, such as auto, yearly, weekly, daily, or assuming no seasonality. By setting this to auto, we essentially give the profit function the power to decide what it thinks might be the best thing to consider. And then finally, the profit model allows for the selection of significant dates to consider when fitting and forecasting from the model. So let's say you are looking at business trends and you know sale of a certain item is going to go up around the holidays. You can specify that holiday or range of holidays within this function to be considered in the model fitting process. So now that we have all of these options specified, I'm going to select all of our models, and we're going to use the default settings, and then we're going to click Run Forecast. So that once everything's set up, you can click Run Forecast. If you click Run Forecast before everything you need is selected, the dashboard will return an error and let you know there's an issue. So this will take just a little second to run, and anytime something is running or the dashboard is thinking, you'll see this loading symbol up here. And as soon as that loading symbol is done, that means you can continue interacting with the dashboard. So when this is done running, you are going to see quite a large amount of output. So we're going to go through this step by step and take a look at everything we get. So starting off first is our formatted forecast. So our formatted forecast means we have a date column, our data column, where our data column corresponds to what was actually observed in each year. And then we have our median, our lower bound, and upper bound. As can be noted for this particular example, which is an ARIMA model, we cannot obtain the model fits, so this is left blank. And as can be seen with the image up here, we do not see the upper and lower 95% prediction intervals. And just to note as well, this red line is just connecting the dots. It does not represent a median model fit. However, we do have our forecast. So again, we are forecasting 4 years out. So we see our 4 dots. And then this red line here corresponds to our median model fit, which you can see by hovering over the line. And then we have our upper bound and our lower bound, which represent our, again, the upper and lower bounds of our prediction interval, which we did select in our sidebar over here. So let's say you're not too thrilled with how this image looks and you want to edit it to make it look a little bit better. You do have this figures options button, which allows you to multiple customizations related to the y-axis, the x-axis, the lines, and the points. So let's say I want to decrease the number of date breaks to every 1 date. So in doing this, as you can see, the dashboard is syncing. So this does take a second to load because it applies to every figure included in this portion of the dashboard. And I'll show you what I mean by that in a moment. So it has stopped loading. So as you can see now, we have each of our years are showing on our x-axis. And then, as I said, we have multiple figures, which we can go through and navigate by using these arrows here. And then additionally, the data down here changes to match what is shown up in this figure. Let's say you want to only look at one type of model. So what you can do then is click this data options button, which allows you to filter the data and figures you're seeing. So in this case, let's take a look just at our generalized linear model. And then we can see only our generalized linear model information. One last thing I want to talk about with the figure and the data we can see here is the option to update the underlying data during the forecast period. So this means if you are doing real-time forecasting where you don't know what's going to happen into the future, and then you want to go back and evaluate that data, what you can do then is upload an updated time series by clicking browse and then looking for the folder similarly to what we did for inputting data. And then what will happen is the figure will automatically update with that data and show you the points. And if you want to revert back to the original data, you can click revert back to the original data. So the last thing here we can take a look at is this cPanels option. So cPanels allows us to take a look at all of our models grouped together in one image for each combination of location, year, and calibration period links. So in this case, this corresponds to the West for a forecast period date of 2017 and a 10-year calibration period. And we can see this in the figure as well. So we have our 2017 forecasting period and then our respective forecasts for each model. And we have, similarly to before, we do have multiple figure options for this. And then we can also download any of our figures and data. So in downloading, you have multiple options as well. You can specify such as your DPI, your figure width and height, how you want to measure that width and height, and then the type of figure you download. And what will happen is that will apply to every single image and then download them all as zip. So like, let's say you download them and you're not too happy with the size of all of the images, you can come back, readjust the size, and then you'll get another zip folder with all of your forecasts. So that is our top panel. And again, we can download this figure as well. We also have our download forecast data button as well. This middle panel here now includes our quantile forecast. So this shows the distribution of forecasts across different quantiles. So it still contains our forecast and model fits. So like I explained before, for the ARIMA, we can't get our model fit. So therefore, we only see the forecast in this case. And then this is the forecast from which the formatted forecast is derived. So the formatted forecast, again, shows our observed data, our median, which is this first column, and then our lower and upper bounds. And as we're working with the 95% prediction interval, that comes from our lower 95 and then our upper 95 columns. And as above, you can filter the data to look at specific quantile forecasts, and you can also download all of the data sets as within a zip file. The final option we can see on here is our time series. So this plots all of the available data and locations you specified over time. And as before, you do have multiple figure options as well. So we can specify anything about our title, our y-axis, our x-axis, and our lines. So let's say in this case, I am working with cases instead of counts. So I want to specify, oh, I did that in the wrong place. I want to do it in my y-axis. And instead of counts, I want to say cases. So that will apply to the time series graph and allow you to download a customized figure. So to download the figure itself as above, you will click the download button and you will get a bunch of options of how you can save your figure and then be able to select the folder you actually want to save it in. In this case, as there's only one time series figure, you will only get a one figure output, not a zip folder in this case. Then finally, we also have our show underlying data option. So this just shows your time series data, and it's a good way to check to make sure everything was read in correctly as well. So again, we have our year column, and then we have our Midwest, Northeast, South, and West. So that is a quick overview of everything on the forecasting page. So let's navigate over now to our model metrics page. So this is auto-populated based upon the forecast you just run. So the model fit page, in this case, so the select metrics to show model fit, or will provide model fit statistics whenever available. So there are some instances where you cannot get model fit statistics. For example, at the ARIMA, you can't get it for MSC, MAE, PI, and weighted interval scores, as that requires information about the actual model fit. Therefore, we cannot calculate that. However, the auto ARIMA function does provide values of AIC or corrected AIC, AIC, and BIC. And this top panel here shows our average model fit metric. So when I mean average, it is the average metric across forecast period dates. So looking at down here, it is each of these rows holding the location, model, and calibration period like steady. What is the average across all the dates that meet the same location, model, and calibration values? We also get a image related to this as well. And we'll get one of these images for each of our included metrics. So in this case, this is for our mean squared error with a calibration of 10 years. And then our x-axis will be the available models, and the y-axis will be our locations. You do have quite a bit of customization options as well. So we have our y-axis customizations, our x, our fill. So this is things you can specify the colors, the numbers that show. We also have some information related to the legend. We can also download all of these figures just like before. And I know I just mentioned this, we also get crude metrics. So this is for every forecast that is conducted, we get one line that corresponds to whatever model fit statistics we can get. For example, we ran one forecast that corresponded to the Midwest with the ARIMA model with a forecast period date of 2017, and we used 10 years of data. And from that, we can get information about the corrected AIC, the AIC, the BIC, the actual model specification. So this is the best fitting model per the auto ARIMA function. And then some other information with some ARIMA testing output we get as well. For other things, we get our mean squared error, mean absolute error, the PI, and the weighted interval scores, and that happens when the model fit statistics are available. And then on this page as well, we also get figures. So in this case, the figures will look different depending on how many forecast period dates that are selected. So if only one forecast period date is selected, like 2017 in our example, we will get a bar chart, which will show for the four main statistics. So these are the four most commonly used and employed in our dashboard. you will get to compare model to model how they do. And again, you have multiple figure options as well and can download everything as before. This last panel down here provides our Winkler scores and skill scores. So Winkler scores are essentially a way of standardizing the prediction interval to allow for easy comparison. So if the prediction interval is not available as like with the ARIMA model, you will not get a corresponding Winkler score. And then you can also average the Winkler scores. So as before, this is just holding location, model, and calibration steady across all forecast period dates. What is the average score? And then finally, we get our skill scores. So this is where we can compare a baseline model to a comparison model to get percentage of how much does one model improve upon another. And we'll get that for each metric and then for different combinations of baseline and comparison. So this ultimately produces a lot of information, so you can filter to see specific combinations of models. Or like with the Winkler scores, you can also use the average metric as well, which is again averaged across forecast period dates. You also get all of this information for the forecast as well. However, it is important to note if you are forecasting into the future and the data is not available to evaluate your forecast performance, you will get a warning letting you know that. However, in this case, we are okay. The data is there and we get all of the same information as before. However, it corresponds to how well did our models do during forecasting. And one last thing to note on this page, similar to what I talked about on the forecasting page, we can actually upload a different comparison time series data file. So let's say this is a real-time forecast. You get some metrics, you know, a little bit about what's going on, but 5 years down the line, a more updated data set comes out. What you can do is upload that updated data set here. And then that will be used as a comparison or like truth data in all of the model metric calculations. And then once you actually have selected a file, you can flip back and forth between using the original data and the new data with this check mark. And the original or the new data, it does have to include additional dates compared to what is in there now. And there are a couple error checks built in. The dashboard will let you know if you need to reformat anything. Finally, we have our model comparison page. So this is where if we have models that are not included in the dashboard that we want to take a look at compared against the models in the dashboard, we can do that on this page. So you will see a pop-up when you first get here with some instructions, and it points you to the About tab because this does require some more specific specification in the files. But we're going to hit OK for now. And we're actually going to navigate away from the dashboard for a moment to take a look at how we need to structure our data. Starting first with forecast files. So these are forecasts that correspond to non-ARIMA, GLM, GAM, or profit models. So we're going to go back to our folder that we downloaded, and specifically to that tutorial folder. And we're going to take a look at one of these files that start with NSC. And I'll talk about what NSC means in a moment. But let's open this up. So as you can see, this looks very, very, very similar to what we were looking at before with the formatted forecast. So here we have a column that's a date, our data, which is our observed data, our median values, our lower bound, and our upper bound values. So it is important to know, in this case, the lower bound and upper bound, the app or the dashboard will assume that that corresponds to the same quantile as used for the dashboard models. It does not know if, let's say you chose a 70% prediction interval in the dashboard, but this corresponds to a 95% prediction interval. The dashboard will not know that. So just keep that in mind when you're using the dashboard. And the only thing you need to make sure here is your column names are date, data, median, median, lower bound, and upper bound using the same capitalization I use. And then with date, as we're using yearly data, this can just be specified as a year. Working with daily or weekly data, please make sure you do year, year, year. You use a 4-year, 2-digit month and 2-digit day format. And if you're working with time index data, that should start at time point 1. So once your file is set up, you do have to be a little bit careful about how you specify the name of your file. So let's go take a look at our names. So here you can see we have 4 files that start with NSC. So the NSC corresponds to the overarching modeling framework that the model used to produce this forecast falls into. So NSC is the end sub-epidemic framework, which is a different type of mathematical model. And then Ensemble UW, so in this case, that is the name that I use to let myself know that is the model that produced that forecast, and that model falls within the end sub-epidemic framework. And then we have the word horizon, so that does have to be lowercase. And then our horizon numbers. So the app will only let you load files that have the same horizon number as what you indicated in the dashboard. So if I set this to 1 and try to load it in, I would get an error. So in this case, I'm working with a 4-year horizon, or forecasted 4 years out. So that's set to 4. And then we want the word calibration, and then the length of our calibration period, then our location, and then our forecast period date. And the forecast period date formatting's a little different depending on what type of date you're working with, and I'll talk about that in a second. However, I want to hop back to this location here. So this, you just need to make sure that the spelling and capitalization you use is the exact same as how you specified it as a header in your original data. So what the dashboard does is it compares that specific location that you specify in your file name against all of the available column names in your data. And if they do not match, you will get an error letting you know to check your file name. Then, as I mentioned, with the specification of the forecast period, the year is the exact same as it's been with any of the other files we've looked at. However, for daily and yearly data, you need to make sure in this case, it would be the month, the day, and then the year. So the 2-digit month, the 2-digit day, and the 4-digit year. However, I'm going to go back to 2017 because that is the forecast period date we're working with. One last thing to note, these do need to be CSV files. So let's go back to the dashboard and load those up. So in this case, we can actually load more than one file at a time now. So I'm going to highlight all 4 of these and then click open, and you'll see upload complete, and then the dashboard's thinking. And what you'll first see is our forecast files. So these correspond to our, or these essentially are plotting the data that we have, or plotting the data that we read in. And we can also say show the panel figures. So the panel figures are similar to what we looked at on the first page. However, it will now, when things match up, and I'll show you what I mean. When things match up, we'll plot all of your models together. So it allows and helps facilitate a visual comparison of the dashboard models against outside models. So in this case, this means we have our 4 outside models, which were for the Midwest, with a forecast period date of 2017 and a 10-year calibration period, which matched one set of our dashboard models. So everything was then plotted in the same panel. However, as you saw before, we also ran more forecasts, and if there isn't outside models to match that, they are just plotted as the same, similar to the panel figures we saw on the first page of the dashboard. We also have figure options, so we can customize all of our figures and then download them as well. And then down here, what we'll see, we get our Winkler scores as before, and it's the exact same as the model metrics page, but now you can see it also includes the and sub-epidemic options as well, which are those outside models we read in. So the last thing we need to talk about is the performance metrics. So let's say you ran all these models and you want to compare how well they did in forecasting or model fit against dashboard models. What you can do then is read those extra metrics in. So the last file we need to do that is the one called performance. So in this case, let's open it up first and take a look at its structure. So there is a little bit more flexibility in how you can structure this file compared to what we just talked about with the outside forecast files. However, the first three columns are the most important, so they do need to be called location, model, and date. Whereas the location corresponds, of course, to the location that used for the forecast and the forecast that produced the metrics. And then we have our model. So this is just the model the metrics came from. We have our date. So this is our forecast period date. And then this again follows the same formatting as the forecast files. So either 4-digit year or the 4-digit year, month, day option. So like that. And then the last columns correspond to your model fit or forecasting metrics that you have for your outside models. So I'm going to clean this cell up. So as you can see, for each of these model and location date combinations, we have a mean absolute error, mean squared error, our prediction interval coverage, our weighted interval score, and then for 2 of the 4, we have our corrected AIC and relative likelihood. If in some cases you do not have performance metrics for a given line, just leave those blank and R knows what to do and how to handle those blanks, but they do not need anything in there. The last thing we need to do is specify a few things in the name of the file. So it does need to start with the word performance. And then next we need to specify, does our file contain forecast performance metrics or fit? In this case, we use forecast to indicate forecast performance metrics, or if we had fit metrics, we would call this fit. The horizon and the calibration are the same before as with the location and the forecast period date. And last but not least, this does have to be a CSV file as with every other file you read into the dashboard. Finally, what we can do is load our performance metrics by clicking browse, finding our folder, letting the dashboard load, and then we do get quite a bit of output as well, which is similar to what we were looking at before on the model metrics page. I'm not going to go over this in too much detail, but I just want to let you know you get this as well. So that is a overview of StatModPredict. Again, the link to the associated code can be found underneath the video. And as always, if there are any questions, please reach out. Our tutorial paper can be found at the suggested citation link at the top of the About page, along with our email or my email with any questions, which can be found here as well. Thank you.